Rethick from ITG2. My number is 22I350. I'm here to explain two questions given by RECode. Let me explain the first question. Given two strings, word 1 and word 2, return the minimum number of operations required to convert the word 1 to word 2. You have the following operation, three operations permitted in a word: inserting a character, deleting a character, and replace a character. First, in the example 1, they have given the two words horse and ROS. We can see that the output is 3. The minimum number of changes or the operation takes place is the count 3. First comes the explanation. For the word horse to change into ROS, we have to first replace the first letter H to R, and we have to O is same, and we have to change the removing R, and we have in the third step we are removing the E, so it can become the given ROS. In the example 2, input is a intention, and the output to be expected is execution. You can see that the output is 5. We have made 5 changes to the word intention. First we are removing T, and then we are replacing I with the E, and replacing N with X, and replacing N with C, and inserting U. Let's start the code explanation. I have created a class named min distance is defined. This class will contain our method for calculating the minimum edit distance between two words. Inside the min edit distance class, there is a public static method min distance. The method takes two strings word 1 and word 2 as input parameters. Returns an integer representing the minimum edit distance between two words. The method will calculate the minimum edit distance between word 1 and word 2 using dynamic programming. Now here we obtain the lengths of the input strings word 1 and word 2 and store them in variables m and n respectively. We then create a 2D array dp of size m plus 1 and n plus 1 to store the minimum edit distance between the prefixes of word 1 and word 2. The extra one is added to accommodate the base causes. Next, this section actually initializes the dp with the base cases. It sets dp of I of 0 to I for I from 0 to m, representing the case where one string is empty and the other string requires I insertions to match it. Similarly, it sets the dp of 0 of j to j for j from 0 to n, representing the case where one string is empty and the other string requires j insertions to match it. Now this part actually fills the matrix dp with minimum edit distances using dynamic programming. It iterates through each cell of the matrix starting from 1 to 1 to 1 to n or m to m. If the characters at the current positions word 1 and word 2 are equal, it sets dp of I of j to the value of top left diagonal cell, indicating no edit is needed. If the characters are not equal, it sets dp of I of j to the minimum 3 neighboring cells, actually representing the deletion, insertion, and substitution operations respectively. Then 1 is added to the minimum value to account for the current operation. Finally, the method returns the minimum edit distance in the last cell of the matrix dp, which represents the minimum edit distance between the entire strings word 1 and word 2. Now the main method. Inside the main method, a scanner object named scanner is created to read the input from the users. Now let me run the code. Yes. I think the first example is suited. First word is given as horse. and the second word is rows. You can see that minimum edit distance is 3. This is the required output, first test case. And for the example 2, let's run it again. Execution. You can see that the minimum edit distance is 5. That's it. Now let's start the second question. Let me read the question. Given the head of the non-empty set linked list representing a non-negative integer without leading zeros, your task is to double the each node's value in the linked list and return the head of the modified linked list. Now you see in the example 1, the given linked list contains nodes 1, 8 and 9. The input first line consists of the number of nodes, and the second and then further consistence of nodes. The output is 378 because the into 2 189 into 2 is 378. Actually, what is to be done is you have to double the total number as the nodes carrying it, and the nodes are printed respectively. That's it. It is also similar to example 2, like 3 numbers. The triple line is given as node input, and the output is 1998. It is the multiple of triple line into 2, and that is the answer. We have to give the 1 as head of the node as the output.